This unit is going to be centered primarily around matter, the changes that matter undergoes, and the properties that we can measure regarding matter. Chemistry as a discipline is the study of both matter and energy, and here's the most important word, how those two things change, oftentimes together. You're going to see these words come up, physical versus chemical, several times throughout this unit. A physical change is a change in which we are maintaining the identity of a substance. So when something freezes, like water, it's still water at the end of that process. A chemical change, on the other hand, takes substances that have a certain chemical structure, such as 2 atoms of oxygen and 2 atoms of hydrogen bound together. That's hydrogen peroxide. It breaks down into oxygen gas and water, 2 entirely new substances. That's a chemical change. And primarily in chemistry, we're more concerned about these types of chemical changes. Matter is defined as anything we can measure the mass of, the SI unit of which is kilograms, or sometimes we simply just use grams to measure mass, or anything that takes up space. If it has a volume in meters cubed, or we can measure its volume in some denomination of liter. If both of those things are true, it's matter. Atoms are matter because they physically take up space and they also have a mass associated with them. There are things, however, that exist that aren't matter, such as light. Light is something that carries energy, but it doesn't have mass. We're going to study light in greater detail in a later unit. But for the time being, just recognize that there are things that exist that don't possess the quality of matter. Physical versus chemical change. The definition of a physical change is a change in which the identity or the composition of a substance does not change. The chemical structure, the atoms that make up the substance, remain intact in the same type of substance is present at the end. A chemical change, however, is where the identity or the composition of a substance does change, such as the act of exploding. If something explodes, such as a firework, the gunpowder and the other chemicals that are inside of the firework undergo a change in which the atoms rearrange and form entirely new substances. Chemical changes and physical changes are verbs, they're actions. Let's see if we can identify some other things that are physical and chemical changes. Pause the video and see if you can come up with a list of at least 3 physical changes and 3 chemical changes. Physical changes are changes where the state of matter can change, but not the identity of a substance. So we already said earlier that freezing, right? Freezing can be an example of a physical change. Any type of phase change from solid to liquid and gas or vice versa is actually classified as a physical change. Crushing. If we take a larger piece of a substance and break it into tinier pieces, it still is that substance. Bending. We take a piece of metal, we bend it into a different shape, it's still the same metal. So bending would be a physical change. Chemical changes. Burning. You take a piece of paper and you burn it. The carbon and the hydrogen and the oxygen atoms in the paper recombine and you get carbon left over and water vapor and CO2 gas. Burning is a chemical change. A slower chemical change would be rotting. Like if you leave a banana sitting out and it rots and it changes color and it gets stinky, that banana is no longer a banana after the process of rotting. tiny little organisms have gotten into the banana, started to break down the chemicals that are in the banana. That is a chemical change. So we have burning, we have rotting. Another example of chemical change is digesting. When you eat food and it slowly digests over time, the food is being broken down chemically. So we have burning, we have rotting, we have digesting. Rusting is another example of chemical change. It happens very slowly over time. Those are all examples of things that change their chemical composition. The best way to identify if you actually have a chemical change going on is when two or more of these things are happening simultaneously. The first of which is when you're forming a solid. If you form a new solid at the end of a process, you're probably dealing with chemical change. If you see bubbles, that means a new gas is being formed. And if you see bubbles being formed, that is also evidence of chemical change. If the substance changes color, that also could be chemical change occurring. And if you see heat being released or heat being absorbed very quickly, that also could be indication of chemical change. And usually, you're looking for two or more of these things to happen at the same time, because you could argue, well, formation of a solid, well, freezing forms a solid, but if two or more of these things occur at the same time, it's probably a chemical change. Properties are qualities, adjectives that we can measure about substances. A physical property is a property that can be measured without changing the identity of an object. An example of a physical property of matches would be, okay, let's measure the length of those matches. You put a ruler next to the match, it doesn't take a chemical change in the match to measure how long it is. You can just set a ruler next to it, the match is still intact at the end of that. A chemical property is a property that, when measured, causes the identity or the composition to actually change. A match is flammable. Flammable, adjective, a quality of that match. The only way that you can test the flammability of a substance is if you actually burn it. So another way of saying this is, if you want to know whether or not a property is a chemical property, can you measure that property without causing chemical change? If the answer is no, then it is a chemical property. So let's see if we can come up with at least 3 examples of physical properties, and see if you can come up with one more example of a chemical property. Pause the video and see if you can come up with that list on your own. Physical properties. A physical property could be the freezing point of a substance, because you can measure the freezing or the melting point of a substance by simply causing a phase change. Another physical property would be mass. You can measure the mass of an object without changing the identity of that object. Color. You can observe the color of an object without actually changing what the object is. 2 other examples of chemical properties. Corrosiveness. Corrosiveness is how acidic or basic a substance is, and it causes chemical change when it corrodes something. Corrosiveness is a chemical property. Reactivity. Different elements on the periodic table are different levels of reactivity. They have different levels of reactivity, and they react in different ways. Intensive versus extensive properties. Prefix in, inside, within. A property whose magnitude is independent of the size of the system. An intensive property is a unique quality of whatever substance you're dealing with. EX, prefix, outside, gets bigger. A property that is dependent on the size. It gets bigger or smaller depending on how much of the object you have. Sulfur. No matter how much sulfur you have, it's always yellow. It's always going to melt at the same temperature. Those properties are unique to sulfur and are independent of whether or not you have large crystals or powder. However, the larger the amount of sulfur you have, the bigger its mass is going to be, and the bigger its volume is going to be. If you have a smaller amount of sulfur, the mass goes down and the volume goes down too. Those are extensive properties because they're changing outside of the amount of material that you have. Our next mini lecture will deal primarily with the states of matter and the phase changes that they undergo.